candidiasis, also vaginal infection. So here are the yeast forms. Here's the hyphae, or sometimes pseudohyphae. So that's a candida vaginal infection, a yeast infection. Protozoa. This is trichomonas. I'll go through the slides. So this is trypanosoma, either cruzi or brucei. Trypanosoma cruzi is from the kissing bug. Brucei is from the tsetse fly. Both of those are insect-borne infections. They're in the blood. A patient would have systemic infection, signs of systemic infection like fever, malaise, general feeling of terrible because their blood is infected with protozoa. Here's another protozoa. This one is leishmania. This one is from the sand fleas, and it's aerobic. It's one of our pustular or purulent rashes. This is Trichomonas vaginalis. This one is sexually transmitted. This could be a swab from a penile swab or from a vaginal swab from a patient. This is Giardia lamblia. So the difference between these, Dr. Vitlino and I were just kind of cross-comparing these two that look similar. So Giardia, they look like they have the eyeballs and they have tons and tons of little flagella. These are their little suckers that attach to the lining of the intestines. There's a ton of flagella. And then here with Trichomonas, they don't have all the flagella. They usually just have one. This one looks like it has two, but they have one. And then they have this line down the middle and you can't really see any flagella. And then here is any of the non-modals. All the non-modals look really, really similar. So I wouldn't ask you the difference between a non-modal and a microscope. You would just know that this is a non-modal protozoa, such as Plasmodium falciparum, Cryptosporidium, Cryptotoxoplasmos, Cysto. All of those are all non-modal protozoa. Here's an amoeba. We have a really cool slide of an amoeba. Amoeba is one of our, causes amoeba dysentery, fecal orally transmitted. These are called pseudopods. That's how they move around. What else do I want to say about that? Entamoeba histolytica, you'll have to know that, but that's one of the most common. So under 400 magnification, they're very, very large. So those are just, this is B. coli. I wouldn't ask you about B. coli because it looks too similar to a cyst. You can't tell the difference between this in the microscope and this in the microscope. But that's B. coli. They're not very common, but it is a gastrointestinal infection, fecal orally transmitted. They move around by these things called cilia. Okay, so that is, so you guys can keep working. I'm gonna pull up a slide of a living euglena. So they're in every pond that you go and find near you. We keep a backstock of them alive, but you'll be able to see them. I'll put them up on the screen and you'll see their flagella moving around. So you'll be able to see like a living protozoa, what a living protozoa looks like. So I'll make a little wet mount. It's called a wet mount. You put one little drop onto here. The technique is holding, I know we haven't done very many wet mounts, holding the cover slip at 45 degrees and then dropping it, and that helps prevent getting air bubbles in there. Even though sometimes air bubbles are beneficial when you have something that moves around because they get stuck and they can't move. So, or sometimes you can use something like glycerin so they move real slowly. But yeah, I'll show you what they look like up on the microscope. As soon as you guys are done with your questions, you can move around the sides and check and see if there's anything that you're missing. I can go back through pipettes with you. We can go back through any of the like plate counts or anything like that. I guess we only have 10 minutes left, but you are welcome to ask any questions. Sorry, go ahead.
Is the wet mount procedure